So let's talk now about the final type of two-stage completion methods. And these, of course, are going to be the ones that will be triggered when either of two previous stages complete. So not both, but either. And that, of course, is essentially logical disjunction. So it's an OR style operation. We'll start out by talking about acceptEither. So acceptEither is going to be triggered when either of its completable futures finish. It's kind of like the famous scene from The Matrix where you get to choose the blue pill or the red pill. And the consumer action that's passed in will be called to handle the results of either of the previous stages. Once again, as with then combine, there are two completable futures that are used here. The one that's used to invoke acceptEither, which we don't see because it's part of the way that non-static methods are called in general. And then the second one is the other parameter that's passed to acceptEither. This particular method returns a future to void, meaning that there's no value coming back. It's just a side effect. That's why we use a consumer. But you do get back a completable future, which you could join on if you want to wait for it to be done. There's other things you could do with it as well, of course. As with then accept that we talked about, this method can be called at the end of a chain of completion stages. So acceptEither is kind of like then accept, except you can have it be triggered when either of the two previous stages complete. So once again, we show our caboose here. And let's take a look at an example. This is a really fun example, and I've actually got some neat code that shows how to use that in the EX8 project in the Java 8 folder in my live lessons GitHub repository. So what we're going to do here is we're going to take a list, and we're going to quicksort it and merge sort it in parallel. So remember all those courses you took with data structures or algorithms where you spent a lot of time doing asymptotic time complexity to try to decide whether quicksort would be better than merge sort or heap sort, and so on and so forth. There's all kinds of math and clever use of proofs and so on to show which one's going to be better. It turns out in practice, we don't care. We don't care if quicksort is faster than merge sort or heap sort is faster than insertion sort or whatever. Because we've got such a proliferation of cores nowadays, we simply run them in parallel. So they both run in parallel, and then we get back two completable futures, and then we use the acceptEither method, which says, I don't care which one finishes first, run this action on whatever gives the value back. Pretty cool, right? So that way we don't have to fret about the asymptotic time complexity. We just let the CPU run away, and we'll see which one wins. And as you probably may also remember from your algorithms or data structures courses, it depends a lot on the data as to which one runs faster. So certain implementations of quicksort work better or worse under different circumstances, and same thing is true with merge sort. So let's just try them both and see which one works better. In this case, you get back the result, whichever one happens first, and in this particular case, we're going to go ahead and print the results out. So we're going to print out the sorted results of the big fractions after we sort them, from whichever one finishes first. Notice, and this is important, acceptEither does not cancel the second completable future after the first one completes. So if you really want to cancel it, you're going to have to kind of stand on your head because it's hard to cancel completable futures in general. But acceptEither does not try to cancel it. So the other one will just run, but its result will be ignored. Remember that because when we talk about reactive frameworks later, you'll see that some of their methods for doing this will, in fact, automatically cancel the other computation or computations. Note that you can use acceptEitherAsync if there's a long duration consumer that's going to run after you're finished. Now, in this case, we were just printing the results, so that's probably not too long duration because we're just printing out the results. But if you were going to do some other long thing, you can use acceptEitherAsync, and that will then do that computation in some background thread in whatever thread pool is associated with this particular chain of completable futures. So another really cool example that hopefully will give you a better idea of how to use these methods in practice.